Dear students, so this is the third part of our unit 3, wherein we are going to talk on Keras, its introduction, and the common functional modules. So, what exactly is a Keras, right? Keras is an open source neural network computing library which was mainly developed for Python language, and it was written by Mr. Charlotte. Now, it is designed as highly modular, it is extensible, and a high level neural network interface. It can help the users to quickly complete the model building. Model building is very smooth when you take Keras. Like, I taught you back propagation, and I taught you a code where you were writing every calculation with respect to back propagation and all, right? So because of these higher level libraries like Keras, model building is very easy. You do not have to have an excessive professional in-depth knowledge what is going behind each and every module. You simply use a module and it does its functionality. You need not write code for it again. I hope you're getting it. So the Keras library is divided into a front end as well as a back end. Okay. Backend generally calls the existing deep learning frameworks to implement the underlying operations like Theano, TensorFlow, etc. So you do not have to learn, have to have an explicit knowledge about coding of all these algorithms. All you're doing is calling a particular function or a module and your work is done. So that's the beauty of Keras. So the front-end interface is like a unified set of interface functions which are abstracted by Keras, and users can easily switch between different backend operations through Keras. From the year 2017, most of the components of Keras have been integrated into TensorFlow framework. I already taught you on various frameworks of deep learning in my previous uh, sessions, wherein I taught you separately about TensorFlow as well as Keras. But from 2017 onwards, it has been an integration of TensorFlow as well as Keras. In 2019, Keras was officially identified as the only high-level interface API for TensorFlow 2, which was replacing all the high-level interfaces like tf.layers that we used to use in first version of TensorFlow. Now, in other words, what you can do is you can only use Keras interface to complete the TensorFlow layer model building and training. In TensorFlow 2, Keras is implemented in tf.keras submodule. So that's a submodule. Once you invoke it, you can smoothly carry out all your coding with that. Now, common functional modules we are going to see. So we all know that Keras is a very popular deep learning framework which provides a very high level API for building and training the neural networks. Also, it offers you a variety of common functional modules, what they are useful for to construct the neural network architecture. So it provides you a series of high-level neural network related classes and functions. For an example, to load a particular data set, there are some inbuilt classic data sets which are present inside Keras. You can directly load them. Network layer classes, model containers, loss function classes, optimizer classes, and classic model classes. In other words, you can very beautifully use all these neural network related classes and functions without actually understanding what is happening inside it. If you know the structure of how to build a neural network, then you can very beautifully use this Keras and build it without knowing in depth what is happening. Now, that's what generally happens. But because this is our syllabus in depth, so first we studied everything in depth. Now we are introducing Keras to you. Otherwise, if you go for any new online tutorials, they directly help explain you with coding part. And they are not going to tell you what is happening inside these classes and functions. We have learnt it thoroughly, what happens in gradient descent, what happened in back propagation. Now we will see how Keras helps you encapsulate all of these things. So when I talk on common network layer classes, for the common neural network layer, we can use the tensor mode of underlying interface function, which is generally tf.nn module. Okay, so there are large number of common network layers which are provided in tf.keras.layers, such as you can have different layers like a fully connected layer, you can have an activation function layer, you can have a pooling layer, convolution layer, all these things you will see in CNN. And also you can have an RNN layer, that is recurrent neural network layer. So all these things are inbuilt, you just are invoking and using it. So for all these network layers, you only need to specify a relevant parameters of that network layer, and you can use a call method of that particular layer to complete the forward calculation. You are not writing any algorithm so far for doing all these things. So building a particular model will be very easier and less time consuming with this. I'm showing you a very simple example on how to create a dense layer. So you are seeing that simply from Keras layers you are importing dense layer, and you're specifying the parameters here like 64 units and an activation function, that whatever you want to use over here. Similarly, when you go for a CNN designing, you will call convolution layer. You can go for conv 2D layer, conv 3D layer. More on these you will study when I'll teach you CNN in depth. So for an example, if you want to call a two-dimensional convolution layer, you will call using conv 2D name, and then you'll pass the parameters, how many filters you want, what should be the kernel side, and what should be the activation function. So very simply, you are just wrapping up the entire building of this convolution layer in just 2 lines of code. Now we'll talk about what exactly is a network container. Now for common networks, we need to manually call the class instance of each layer to complete forward propagation operation, right? So when the network layer becomes deeper and deeper, then what happens? You have several number of layers. So this particular part of code will become very bloated. It will become very complex. So Keras provides you a network container. That means multiple network layers can be encapsulated into a large network model through a network container. For an example, in Keras you have a network container called sequential. You might have come across this in whenever you went through any random code in Kaggle or GitHub. You use a sequential method. What exactly is this? It is nothing but a network container. So when you have working with so many number of multiple network layers, to avoid complex code, you simply use a sequential container. So only the instance of the network model will needs to be called once in order to complete the sequential propagation operation of the data from the first layer to the last layer. We are talking about the forward operation here. Okay. So for an example, if I take here from TensorFlow Keras, I am importing layers as well as I am importing a sequential container. So you can see using this sequential, now I am creating a network. In that, now I am calling my layers, whatever that I want to build. For an example, the first I want to create a fully connected layer with 3 units. I am not using any activation function. Then I am calling an activation function layer with a relu activation function. That's another way of building it. So layers.relu here I am calling. I can again build a second layer of dense layer or a fully connected layer. See here, dense is nothing but a fully connected layer. The other, there is the they are all, it means all the same. Dense other name is fully connected layer, dense layer. So again I am building different layers followed by their activation function layer, and I am encapsulating this entire thing into sequential container. So that's how you can build a network using a network container, a big network. Especially it is used in when you are creating more complex type of neural networks. Now the sequential container can also be used in another way. So what is the another way? The sequential container can also continue to add a new network layer through the add method. Alright, so you can dynamically create your own network. So here you see there's a difference in how I am writing my code, right, than the previous one. So you can see one second. So I was telling you, you can see here this number of layers that I am building is 2. I am creating an empty container. Now this is important, guys. So when I went through this previous code, you can see how it was. Here I'm not here the difference is, just have a look at the sequential part. When I wrote this, the sequential container is not empty. Inside the container I am calling the layers. Okay, so that's how we were building, but there's another way to that. So if you can see the next one, when you're using an add function, then for that first what you have to create is an empty container. So once you create an empty container, you can keep on adding your layers. It becomes a bit more flexible for you. All right, so that's another way of using a sequential container. So thus, Keras and its network container will help you to dynamically create a network without creating any problem. Even if you are adding certain more layers to it, forward propagation or back propagation is not much a cumbersome process, uh, rather than writing algorithm for each and every layer. So we can very easily create or delete any extra layer based on it. Is really helpful for you, to avoid overfitting or underfitting, by adding layers, by deleting layers, whatever best you can do for your network. So this is something which is very very good. uh, Keras network container, and Keras is as a library, it made our process of coding very very smooth. So this was about introduction to Keras and its network container. We are going to see how do we create a model, load a model, save a model in our next class.